Beth and Hillary here, and we are going to be showing you SOS Explorer Lite today. Have you downloaded it yet? It's freely available on our website, and we love it, and we want you to love it.
And it's just
too.
been updated, actually. So there's a few new data sets that weren't there before if you have downloaded it in the last couple years. Here's the link. Go to it, download it, especially if you're a teacher. This is a free version, and we're going to show you exactly what we're giving you today.
Yeah, so we're using SOS Explorer Lite today, walking you through some of the tours, showing you everything that we've included. Really a pretty powerful package with just 15 or 16 data sets, but a lot to offer.
That you can put on any Mac or Windows laptop or desktop, so hopefully you can use it in the classroom or to give presentations. That's what I do with it.
Yeah, so what we're looking at right now, the first frame that always opens up is a real-time view of the clouds around the Earth and where the day-night terminator is positioned. So daytime in the US right now, nighttime on the other side of the globe. But, Hillary, can you tell me a little bit about what we're seeing right here?
I'd happily tell you what we're seeing here. And this is because I feel really attached to this particular cyclone that is now a hurricane. Mm-hmm. I believe it's a Category 2 hurricane.
Down to 1 this morning.
Is it down to 1?
Yeah.
So we are happy that it's degrading. Obviously, there really aren't any islands or anything in the path right now. So,
no damage.
But its name is Hillary, and it's actually spelled just like my name.
Excellent.
Which is kind of fun. And there's some really interesting things going on with these 2 tropical storms.
I see 3.
Well, there's 3, you're right, absolutely. This is
well, it's not one yet, maybe?
I think it's a newly forming system, so
okay.
It's not either yet.
Okay.
This is a tropical storm, I believe, and this is Hurricane Hillary. And this was Irwin, maybe it's a... Oh, yep. Right, because tropical storms get named.
Yep.
But I read yesterday, actually, do you want to go into that while I make my little fun...
So, there's this thing called the Fujiwara effect, and I could be saying that totally wrong, so my apologies if I am. But it's when 2 hurricanes interact with one another, and they described it as like a tango between these storms, and they kind of circle around each other, and if one storm happens to be bigger than the other, and in this case, Hurricane Hillary is bigger now than Tropical Storm Irwin, it kind of ends up eating that hurricane, merging together, and so Hurricane Hillary is going to survive this tango. Irwin's not going to make it. So, Hillary, what are you drawing here for us using our annotation tools that we have on SOS Explorer?
We do have annotation tools, and how cool is that for teachers when they're trying to get students interested in things like tropical storms, right?
Yeah.
We have Miss Pac-Man.
Of
I
course.
was going to actually draw Pac-Man, but then I was like, well, it's Hillary, and I'm kind of feminine. So, so we have Ms. Pac-Man here, and we have cherries, because that's kind of a special prize for Ms. Pac-Man. So, yeah, these are going to interact, and Hillary is meant to either swallow or take over Irwin.
Yeah, and they're going to rotate in a counterclockwise direction around one another, and then Hillary's going to overtake them.
Yeah.
Now, I was curious. You get Hurricane Hillary. I wanted to know if Hurricane Beth is coming, and it turns out no. Hurricanes, they already have the names picked for the next 6 years, and they use those same names every 6 years. So 6 years ago, we had a Hurricane Hillary. Now we're getting a new Hurricane Hillary. So I looked up the names. They're put together by the World Meteorological Organization, and no Hurricane Beths over the next 6 years. Now, if a big storm, like Hurricane Sandy, for example, that name got retired, and a new S name came in. So there's a Hurricane Beryl, so if that ends up being a big storm in the year that it happens, then maybe Beth could slip in. But right now,
there's Beryl.
No Hurricane Beths. So you can look up the list, see if your name is on there, if you want a hurricane named after you. Originally, all hurricanes were named after women, and people decided that wasn't right. So in the late 70s, they switched to the system where we are now, rotating guy, girl, starting with a guy or girl every other year.
Why do they name hurricanes?
It's a great question, and mostly it's because it's easier to communicate about them. So it's easy to say, oh, Hurricane Hilary's out doing this, rather than that hurricane off the coast of Mexico.
Right?
Yeah, and when you have multiple hurricanes, it gets confusing. So starting in World War II, people started kind of calling hurricanes by names. They used their wives' and girlfriends' names. And then in the 50s, it became more official. They gave them some real names, all women's. And then in the 70s, they went to men and women. And it's worldwide. The World Meteorological Organization sets it all up, and there's a whole system there, so you can look them all up.
Typhoons are named too. They tend to have more Asian names.
Yeah, they try and match the regions where they are. And actually, are there other storms going on right now?
Well, you know, we're actually going to show you some of the really cool things that we have in SOS Explorer Lite by showing you some of what we call tours. And these tours, because Science on a Sphere data sets tend to be much better shown with a docent like us. We're showing you things. It's easier to explain in person, but because we can't be there with you, we've included what we call tours. So we have taken all the data sets, almost every data set, and added them to one of these tours so you understand questions to ask and how to move through and string the data sets together. So actually, we're just going to open up the wind and weather tour. We're not going to get very far in this one because we kind of wanted to talk about plate tectonics today, but we're going to just go a little bit into here. And the question right now is, notice the green, blue, and white colors on the planet. The white is snow, ice, and clouds. The satellite imagery shows clouds, which we see today present as basically the weather today. So point out anything happening today. So that's essentially what we're asking students or teachers to do as they're looking at this. So now we can see a flat map.
I've got to take a moment and brag here. The fabulous Hillary wrote all of these tours. And on our website, there's worksheets that go along with the tours. So if you wanted to use it in a classroom or at home as your own little activity, total lesson plan put together for you. So we already showed people the storms near us, but let's check out what's going on in Asia. A couple different storms going on in here. We see lots of activity this time of year, and I'm afraid I didn't look up their names. Did you?
Yeah, so I believe there's a Nauru and one that starts with a K. I can't remember. And then you mentioned the one that was spinning around in Vietnam.
Yeah, I think it made landfall maybe yesterday. So a lot of activity, a lot to keep our eyes on as we're looking. And that's a great thing about Explorer is we get this global view. We don't think about just what's happening in us.
So I'm just going to flip forward one more because here in a second we actually asked people to kind of look between the forecast weather map and what clouds actually look like. So one way to put all of this together, I'm going to see if I can kind of zoom in on this a little bit. But one way to look at this is here's a forecast map of the United States. Here's the actual cloud cover. Can you see the correlation between these forecast maps and what you actually see in weather? So one thing that I notice very much is these blue front lines, so that's
cold fronts.
Almost always tend to be these huge systems. So these large, often really huge as far as like geographically. But also lots of clouds and
we've got
weather
some stationary fronts here when you have the blue and red mixed together, so it's not moving super fast. There's not one air mass dominating the other. And in front of these ones, we can see this red area here. That's going to be some severe weather or interesting weather happening, and no surprise, right in front of that, we see those clouds already starting to form. So eastern half of the U.S. could have some interesting weather today for sure. Looking at this satellite and the position of our lows here, and what's going on.
So a lot of the convective weather would be in front, right? So the tornadoes and really severe thunderstorms.
And then notice this, we've got a high up in Canada, and check out
what's happening there.
What's going on. We say highs are happy. There's lots of clear,
fair
weather going on in those areas.
So anytime you see kind of an area where you don't see a whole lot of clouds, that's typically kind of a high pressure. Cool. So let's quickly get to plate tectonics because we have so much fun talking about weather. We have a meteorologist here,
Yeah.
so that's not a huge surprise. But we also have other really amazing things you can do on SOS Explorer. So we're going to talk about plate tectonics here. So I'm just going to kind of lead Beth through some of the questions that we have here. So have you ever wondered about why the Earth's surface looks the way it does? So take a closer look at some of the features that you can see in this view of Earth. You can rotate the sphere around. You can zoom in. Do you notice any types of features?
Of course, there's a lot to notice on our Earth. And one thing people point out, especially when we're thinking about plate tectonics, is how it looks like Africa and South America are puzzle pieces that fit together. And there's this really distinct ridge going right through the middle of them. So those are some of the things that I noticed.
Great, those are really good examples. So whenever we ask questions in these tours, we also like to answer them for our friends who are taking the tour. So many features like mountains, island chains, and underwater ridges are caused by the dynamic movement of the Earth's crust.
Yeah.
And there are other effects too, which we're going to explore a little bit further in this tour. So now we're showing volcano locations, and then we essentially ask, well, why don't you kind of look around and point out, Beth, any sort of patterns that you see occurring. So notice I can click those text boxes closed. So if you wanted to give this presentation in front of your classroom, you could actually close those text boxes if you kind of know where it's going.
Now, of course, one big thing I'm noticing are volcanoes are occurring in really distinct lines. We get a few random ones here and there, but really along these lines we see a lot of patterns in where these volcanoes are forming, almost circling the entire Pacific Ocean.
Yeah, absolutely. So the Earth's crust is broken up into tectonic plates that move past, towards, and away from each other. And at these boundaries where the plates meet, there are many effects, including volcano formation. So
Sure.
I'm not going to skip ahead any further. We're just going to kind of let things reveal here a little bit.
Oh, yes.
But here's one example of how volcanoes form. So this is one oceanic plate basically subducting underneath a continental plate. So this is plates moving towards each other, causing a large volcanic mountain range. So the Andes in the western coast of South America is a really good example of this.
Sure.
These are really intense volcanoes. They're not very old, and this is also where other intense things happen. So we're going to keep kind of moving forward and learning more about these areas, these boundary areas. So now we can see the earthquakes that have happened over the last week, lowered over the volcano locations.
And what's cool, for both the volcanoes and the earthquakes, if you click on them, you can get a little pop-up telling you about that earthquake or volcano. So when you're playing with it on your own, definitely explore, see what's going on. I looked up this morning, there was a earthquake off of Japan that was a 5.9. So it's the biggest thing happening right now. So pretty calm. Here's a volcano she clicked on. Oh, Baker, that's a really famous.
Yeah, and actually red means something that happened in the last hour.
Okay, so a 2.4. You probably didn't even notice it if you were in Monroe, Washington, but there was a 2.4 earthquake happening there.
So what's cool is you can definitely click on these and learn more about them. But now what can we say about having volcanoes and earthquakes layered over the top of each other? What would you say that you notice?
They definitely are happening in similar locations. We see a lot of, particularly in the Pacific, a lot of overlap. It seems, though, here in Africa, we see a lot of volcanoes, but not a lot of earthquakes.
Interesting. Yeah, so that's not always happening necessarily at the same places. Certainly there are areas where we have different types of boundaries, and different types of boundaries produce sometimes more volcanoes than they do earthquakes.
Yeah.
A lot of the earthquakes that happen at what we call divergent boundaries, and we'll go into that in a second, but really don't produce as many earthquakes as they do volcanoes.
So you've pretty much turned on our answer key here by
Yeah.
labeling all of our boundaries along the Earth's surface here.
Yeah, so we are now layering plate tectonic boundaries and the types of boundaries. So we have divergent, convergent, and transform. So divergent, move apart, convergent, move together, and then we have the ones that move next to each other. So typically, Beth, what would you say the largest... I wonder if you can tell just from the last week's earthquakes.
Well,
do you know?
Certainly, if we're
the
looking
largest
like
earthquakes happen
along the divergent, we don't see a whole lot going on. And transform, you can get some, but doesn't it make sense that convergent, where plates are coming together, we're going to get a lot of earthquakes?
Yeah, not only a lot, but really these are your
right
powerful
here.
ones. So.
Yeah.
If anyone knows anything about earthquakes, you probably know that Chile, Alaska, Japan,
all these big convergent boundaries.
Yep, so these purple boundaries here basically get the largest. But it doesn't always happen on boundaries. So what's going on in places where there's no boundary?
Like Hawaii. We see a lot of activity. There's volcanoes. It's made up of volcanoes. And that's going to be a hot spot.
Oftentimes it's hot spots. Ew. I actually meant to click on Yellowstone. Yeah, Yellowstone is a hot spot, as well as the Hawaiian Islands. And we could go on all day about this kind of stuff. But you also get earthquakes at ancient fault lines, which often occurs in the East Coast. And then you also have energy extraction areas, which sometimes get earthquakes as well.
Definitely. So there's a lot that you can do with SOS Explore Lite even. And we're just showing people a little taste
a snippet
of what it's possible.
Yep, absolutely. And so this is kind of how we conclude this particular tour, is to go into the age of the seafloor.
This is one of my favorite data sets.
Really?
I love this one.
Yeah, why?
Well, because I think it paints such a neat picture. So where we see divergent boundaries, where plates are coming apart, that's where new ocean crust is coming up. And so we see new seafloor. And then no surprise, along convergent boundaries, we're going to see older seafloor. That's where it's getting sucked back in and
recycled.
Recycled, exactly. So I think it's just such a cool picture of our Earth's crust.
One of my favorite things that I learned when I first learned plate tectonics was actually at these convergent boundaries you often also get island formation, because what's happening is you have one plate, the Pacific plate, subducting under another plate, and essentially it's getting recycled and sort of boiled in this mantle, and then essentially the rock pokes up and starts to make islands through the crust, which I thought was amazing, because I basically think, well, this unlocks the entire map for you. You understand what's happening everywhere. So so this is essentially how we kind of finish the tour, is talking about the correlation between the plate boundaries and the age of the seafloor. And then, of course, we kind of give you the answer and say, hey, take a moment to summarize what you've learned. And that's just our shortest tour. We also have a wind and weather tour and an Earth Systems tour. So we really hope you enjoy SOS X Lite.
Yeah, make sure to go to either our Facebook page or our website and download it now.
And also, lastly, give us feedback. We really like feedback. If you click the feedback button, an email will go to us and we'll have your email.
Yeah.
So,
thanks so much, guys.
all right. See you next time.